In this video, we'll cover the problem first bad version. So here we have a product that we are managing, and there's a series of versions of this product, like 1, 2, 3, all the way up until n. Now at some point, or I guess the way they frame this is the latest version of our product fails our quality check. There's some problem with it. But we don't know the first time it broke. Maybe we're on like n equals 8 here. We're on the 8th version, and we know the 8th version doesn't work, but we don't know when it originally broke. Maybe the 3rd version broke, and then everything after that failed. So this is one thing that's important from this problem, is once we get one bad version, everything after it will also be bad. Our job is to find the first version that went bad, so that we can try to correct it. In terms of format for this problem, so it's a little bit different. We have this outer function, and we have access to this input called isBadVersion, which is a function that will take in a version number, say 2, and tell us true if that version number is a bad version, and it will tell us false otherwise. What we want to do is return a function, like implement a function that will find the first bad version. So you can see here LeetCode has already started this for us and telling us that we should be returning a function. So if we sketch this out, we'll use the example I was just describing. So we go 1 through 8. Let's say 3 was the first bad version. So everything 3 onwards we return true. It is a bad version. Before 3 we say false, it's not a bad version. When we view it this way, this kind of becomes find the first true in this sort of Boolean array here, which is like finding the first or the leftmost boundary. And we know how to do that, and we can apply our binary search template to do so. So let's go ahead and do that now. So what we can do here is we will have our left version number, just going to start at 1, because that's where our first version number is. We'll have our right version number, which is going to be n. And then we're also going to have a variable for our output. So we'll call that first bad version number. We want to set that to some default value. And the default value is going to be if we never find what we're looking for. So in this case, if we never find a bad version, what should we return? I'm going to create a constant for this. We'll say no bad version found, which will be -1. So we can initially set our value to this so that if we never overwrite it, we'll return this. For this problem, it doesn't actually matter. I believe the input is always containing some bad version, but I think it is better practice to be handling this case. Also, one thing I would do is I would personally just want to change this to an ES6 arrow function. Okay, so now we can get back to our core logic. So we'll have our while loop. We'll say so long as the left version is less than or equal to the right version. Generally, I think it's better to copy and paste when possible for variable names just to be safe and avoid little typos that are unnecessary. Now in here, we'll say mid version is going to be get mid num. So I'm going to write a generic function here. I'll show you that in a second. And we'll pass in the right version and the left version. So this get mid num, I'm not naming it get mid version because I want it to be generic so that anyone who's working in the code base that I'm working in, whenever they're writing a binary search, which is inevitably going to happen if you're at a large enough company, then they can just simply use this function so that they don't have to think about how to do it, and we are consistent throughout the code base. So if we ever want to change something, we just come to this function instead of coming and changing it in thousands of lines, thousands of files or something like that. This function we've seen before, but we want to get the midpoint between two numbers, and we want to avoid storing a really, really large number in any of our variables. So what we do is we say, all right, I want you to get the distance between the left number and the right number, cut that in half, and then go to that position. That's what this function is doing. All right, once we have our mid version number, we want to see if it's a bad version. So we can say if is bad version of mid version. So that's if the mid version is a bad version, what do we want to do? Well, that means we got a true here, which means either we are currently at the correct answer or the correct answer is to our left. So what we will do is we're going to set our answer to be our current position. And then we're also going to say, I want you to search everything to the left of me. So if we're at a 6, I'm going to say search all this stuff. Search all this stuff. So we'll grab our right version kind of pointer, and we'll move it to be mid version minus 1. So we'll move it, if we're here, we're going to say, all right, search this remaining space. The else case means that, oh, actually one thing I want to mention before we move on. Note that there are two cases right here. Case number 1 is that we have set our correct answer. So that would be like we're here. We set first bad version number to be 3. Then we're going to search everything to the left, but since this is the correct answer, there are no trues to the left, and we will never overwrite this. So we're going to return our desired answer. The other case is that we are not at our correct answer. So say we're at 6, and then we set first bad version number to be our version. Well, we're going to be searching to the left, and since it's not the right answer, there are more trues to the left, which means we are definitely going to overwrite the variable. So it doesn't actually matter that we set it to 6, even though 6 is not the right answer, because we're going to overwrite it later to be the correct answer. So this logic is fine, even though it may not intuitively seem ideal. Now we can handle the else case, which means is bad version is false. So we have one of these cases. So imagine if we were here, well, all we want to do is say, all right, I haven't found the answer, look to the right of me, because obviously it's not to the left of me. If it was to the left of me, then I would have been a bad version, and I'm not a bad version, so it must be to the right. So we'll just grab our left pointer and move it over here. So we'll say left version, it's going to be mid version plus 1. That should be it for our binary search. In the end, we can go ahead and return first bad version number. So let's run our code. Looks like that works. We can submit. Okay, great. Looks like that works as well. So that's all for this video, and thank you for watching.